Hey everybody, we're here on a beautiful spring morning with my beautiful wife Lindsay, and today we're going to be refining some gold. So I've been accumulating some gold off of various sources like eBay and stuff, and what we're going to do is incorporate the gold with another metal. Today we're going to use silver, and this way, by using silver, you can essentially refine both metals at the same time. You can use copper, that's fine too. But we're going to use silver and try to get both metals refined. The reason you want to incorporate the gold, you want to bring it down to about 8 or 9 carat. And the reason for doing that is so that the nitric acid, when we give it the nitric acid treatments, it has a chance to actually contact the other base metals. If you try to do it like now, then the gold would protect all the base metals and you wouldn't get any reaction going. So let's get started. Okay, so now we're going to start the process of incorporation. So I've already got everything pre-measured out for how much silver I need for everything. I got my 18 karat gold, got my 14 karat gold, and my 10 karat gold measured out with its appropriate amount of silver. If you want the exact calculation on how to get your gold down to 8 or 9 carats, then I recommend you watch the videos by Sri Tips. He has several very informative videos on gold refining in general. So I would definitely recommend you watch his videos. But so starting right now, so I got a big enough crucible I could probably get everything in at one time. And so let's get started melting. Super bright out today and I can't see the flame, but it's going now. Okay, it's been only about 30 minutes now and it looks like all the metal is melted already, so kudos to this foundry here. I'm going to go ahead and shut it off. Give it a good stir with our graphite stirring rod. Make sure these metals alloy really good together. Oh, looks like we might end up with a piece of steel or something in there. That's okay, that'll be taken care of during the nitric acid treatments. Alright, now what we're going to do, take our crucible, alright, so we definitely got some down at the bottom down there. Get that steel out of there. Alright, so we definitely don't want any gold left, so we're going to go ahead and reheat that back up and do it again. Okay, so I had to redo one piece that I put in there. I didn't like the way it came out into the pot. So right now we're going to check our second batch here. Give it a good stir to make sure these metals alloy really well.
Hey everybody, I'm back in my garage now. So we got our gold all imported, and so now we're going to start the process of nitric acid treatments. So you can see this is what you want your gold to end up looking like. This is probably around 8 karat gold, something like that, I would guess. So to start this process, we're going to be using distilled water. You must use distilled water because the trace amounts of chlorine in tap water will react with the nitric acid and give you some really nasty fumes. So you got to be careful when you're using nitric acid. This is some pretty nasty stuff. What this is going to do is dissolve all the silver and all the other metals, which is probably mostly copper, and leave behind just the pure gold. So let's get started. As you can see here, I've built a fume hood, and if you're going to ever be working with chemicals or any kind of deadly fumes, I recommend doing something like this. This is to keep me safe during this process. Once I mix the nitric acid, the dilute nitric acid, with the gold and silver, it's going to immediately start to react and produce very deadly gas. So I would recommend doing something like this to keep you safe and still wear your proper respirator. Okay, so for the time being, I'm just going to put on my respirator, and I'm going to start the reaction out here just so you can see it, and then I'll try to set it up to where you can still watch the reaction happening in my fume hood once I put it on the heat. That's when the reaction should actually take off and the silver should start boiling away. We just want to cover the gold with distilled water and then just add a little bit of nitric acid just to get the reaction going. You can see the reaction starts pretty much immediately. So what we're going to do now is put this on the heat and let this cook. We're gonna turn on our fume hood now. I can see the liquid starting to turn a very pretty blue color. That is the silver and copper being dissolved away from the gold. Alright. I'll come back again and show you the reaction after it's been on for a few minutes. Okay, this is only a few minutes into the reaction. As you can see, it's already starting to boil and produce a lot of really dirty brown smoke. So what's happening during this reaction is the nitric acid is eating away all the metals and producing silver nitrate, which gives off a really toxic, nasty gas. So you want to be really careful when dealing with this, but I'm going to let you see it. You got it. Okay, it's been about 30 minutes now. The nitric acid has been boiling. All of the brown fumes have gone away, so that means that the nitric acid is probably out. So what we're going to do now is we're going to take this off the heat and we're going to pour off all the liquid that's on there right now, and we want to save that pretty blue liquid because that contains a ton of silver. And later in the video I will show you how to get all that silver out as well. But for now we're going to pour out all of this into a separate beaker, and get that ready to get the silver extraction. Okay, so this is exactly what we're looking for right here. Almost no color at all, nothing reacting, just highly concentrated nitric acid boiling. This should mean that at least 99% of all the silver and other metals, copper or whatever it may be, are out, and we're left with about 99% pure gold.
About 99% pure gold.
Okay, so we've got our gold down to exactly where we want it. This is why it's important to calculate out the exact amount of silver to encort the gold with, because if you end up using too much silver, the gold turns into a very fine powder and it's extremely hard to work with. And too little, then obviously you're going to end up with base metals in your gold and it's not going to be very pure. As you can see here, the gold held together very nicely. I got some big chunks of pure gold. And this by itself is already about 99% pure gold. But to get it to 3/9 fine, we're going to go ahead and dissolve the gold itself and filter out any impurities. And to do that, we're going to have to make something called Aqua Regia. It means royal water. And to do that, we're going to actually mix hydrochloric acid with the nitric acid. And that will actually dissolve the gold itself, and we'll be able to filter out any impurities. We'll also be able to precipitate out any lead during that process. At the same time too, I decided I'm going to go ahead and start refining my silver also. As you can see, we got a very beautiful blue color of silver. And so in order to do that, we have to get rid of all the free nitric acid that is still in the solution, because there's still, especially from the last pour that I had, there was a lot of nitric acid that was not used up. So what we're going to do is take some more silver and throw it in here. until pretty much it stops dissolving any silver, and then I'll show you how to get it out from there. All right, let's get started. So before I begin, I just want to reiterate that the fumes produced when you dissolve gold in Aqua Regia are extremely toxic and extremely deadly. Therefore, I'm going to be wearing my respirator, and as soon as this reaction starts, I'm going to put it in my fume hood and put it back on the heat. I'm just going to start it out here just to show you guys what happens when we pour the hydrochloric acid on it.
As soon as I pour the hydrochloric acid, it will start to react immediately because there's still some nitric acid attached to the gold in the beaker. Alright, so I'm going to put that on the heat and let it do its thing. Not too much is happening with our Aqua Regia, so I'm going to go ahead and add some more nitric acid. Alright, our silver is dissolving quite nicely. Our gold, the reaction is starting to happen now that it's got more heat on it. And it should take about 45 minutes, I would say, to dissolve all the gold into solution. Okay, I'm going to check and make sure that all the gold is getting dissolved. I'm going to go ahead and add a few squirts of nitric acid since there's a lot of gold left. As you can see, one thing you don't want to do is add too much all at once, or you can get a runaway reaction and cause a boil over, and then I'm going to end up with liquid gold scattered throughout all my entire fume hood. That would be a big mess and a big waste. You'll notice I got it in a Corningware bowl, and I also have a lid on it this time. The reason for that is if I do have a spillover, I want to try to retrieve as much as possible. Also, the gold has a tendency to try to evaporate. And so if any of that does, I want it to hit the plate and try to condensate it back down into the liquid. You can see my silver is really taking off there. It's dissolving pretty rapidly. And so that's a good sign. There must have been a lot of nitric acid still left in there. Okay, so our gold has been cooking for about an hour and a half now. And it looks like it's now completely dissolved into the Aqua Regia. I got a little bit impatient and added a little bit more nitric acid. I hope I didn't add too much, but either way, it won't matter. I have plenty of Metabisulfate. So we'll be able to get it out of there. So let's have a look. You can still see some stuff at the bottom of the liquid, but it's not gold. We're going to let this cool outside now. So the first thing we're going to do is we're going to use some sulfuric acid. We're going to add a couple drops of this, and this will precipitate out any lead to get it out of our solution. Startled me. Okay, we've got our gold into the solution now. This is all liquid gold right here. So the first thing we're going to do, we're going to do a Stannous chloride test solution to make sure we actually have gold in solution. So all we do, take a little drip like that, take our Stannous chloride. Now you see how dark that turns? As a clear indication that there's a ton of gold in solution. Alright, so we're good to go. The first thing we're going to do is filter our solution and to get all this junk and whatever's floating around down at the bottom and get that out of there. Okay, we'll take our spray bottle, and what we do not want, we don't want any waste right now. So we'll just get all this into the filter. Don't want to leave any yellow behind, because that is gold. Alright, now we're going to spray our filter down and get every bit of yellow out of it. looks to be about it. As you can see, we ended up with a little bit of junk. I save all my filter papers. I'm going to extract any gold that gets left behind out of them later. All right. Looks like we got a pretty clean, pretty pure solution here. We're going to go ahead and pour it back into the beaker. Now the next step is we're going to be using sodium metabisulfate, and it's going to actually precipitate all the gold into a very fine black powder. Before I do that, I'm going to let this cool down. It's best for this to work whenever the liquid is very cold. I would put ice in it, however I do not have any ice that is not made from tap water, so I'm just going to have to let this cool down naturally. Okay, for this next part, all we have to do now is to precipitate our gold out of solution using sodium metabisulfate. Alright, now what we're going to do with this is just keep adding sodium metabisulfate until there's no more fumes or any more reaction. After that, we're going to leave it set for a while. I might actually end up leaving it set overnight, and just to make sure we get all the gold out. We use our Stannous chloride test to make sure that everything is out of solution. So let's get to it. I don't recommend doing this outside of a fume hood because this also is going to produce many fumes, but just so you can see the reaction, I'm at least going to start it outside. You see it almost immediately starts to precipitate gold out. Again, you don't want to add this too fast or you can get a runaway reaction. Now what would happen if you use too much nitric acid is as soon as the gold precipitated out, it would just go right back into solution. So essentially, you'd have to knock out all the nitric acid with this first, and it's going to take a lot. Okay, we're going to continue to add the sodium metabisulfite now. See a lot of gold dust forming at the bottom. I'm going to keep going just to make sure. I certainly don't want to leave any in solution. Alright, so I'm going to let that set for a couple hours now. I'm going to come back and give it another Stannous chloride test, and we'll see where we're at. Okay, so we got all the gold out of solution. I ended up letting it sit overnight. I just wanted to make sure I got every bit of it out. So as you can see now, it's all settled down to a very fine gold dust at the bottom. Alright, and just to ensure that we have no more gold in solution, we're going to give it another Stannous chloride test. So we just dip it in there. As you can see, we get no color whatsoever. So that tells me all the gold is out of solution. And now, the only thing left to do is filter this out and get all that gold dust out of there. Okay, we got it all filtered out. We're going to go ahead and wash this off a little bit. See that pretty gold mud down there? We're using filter paper this time instead of a coffee filter because this turns into a very fine powder, and it'll be able to slip through any coffee filter. So we use this filter paper, and that helps keep all of it in. Just takes a little longer. Okay, now we're going to go ahead and try to get all the gold into the filter paper. Okay, so before we actually melt this down, what I'm going to do first is actually give it a little bit of a rinse with some hydrochloric acid, just to clean off any kind of dirt or debris that might have gotten in there. We're going to transfer it into our melt dish and get it ready to melt this down into a pretty little bar. Okay, there we go. Okay, so we got our gold all purified. We got it in the melt dish. All right, so we're going to be using this matte gas to try to melt it. This is what we're shooting for right here. Hopefully we can get a nice little gold bar. All right, so let's get started. Get it out of our mold. So that concludes our gold refining video. So the next video I'll be making is to refine our silver that we still have in the garage, but this is what all the work was for. Pure 24 karat gold. But I definitely know now I need a better method of melting the gold bar at the end, but it doesn't matter, it's still beautiful. Alright, so we're going to get a weight on this thing. 82 grams. 82 grams of pure 24 karat gold. So you can do the math and figure out how much that's worth, but man, that's beautiful. Okay, thanks for watching.